So before we talk about the role that the ocean plays in all of this, we're just talking about how bad will it be? Okay, how much global warming will we get in the end? And as I said before, the average temperature that you can predict, okay, is only a proxy for all the extreme events that actually make up that average value. Okay? So anyway, so what we're talking about is the emission of CO2. Global emissions, which is a proxy for all greenhouse gas emissions. There are other greenhouse gases, but this is often used as a proxy. Okay, so there are different scenarios, and it depends on what happens in the future. This determines how bad it will be. So the most realistic scenario is shown here, as called RCP 2.6, is actually that the CO2 emissions go to very, very low values, essentially disappear by 2070, even turn into negative now. Very, very idealistic and very unrealistic too. Yeah? Why do I say unrealistic? Because we are actually tracking the global emissions of CO2, and this is something that's reported in terms of gaps. Here, for example, is an emission gap report 2018, and there is no indication or whatsoever that that we're actually on the right pathway. Anyway, so the worst scenario shown here by the red curve is called RCP 8.5, and it actually assumes a continuous growth of CO2 emissions and sort of coming to a peak value by the end of the century. Okay, and then you can use climate models, and I told you before that the forecasts are reliable. So not the forecast by one climate model, but if you put them all together, and this is what's usually done, is so-called ensemble modeling. If you look at all the forecasts together and you show the predictions, and then you get a so-called envelope of forecasts. And this is shown here on the right-hand side. Okay, it shows the predictions of a bunch of climate models, and you get an average prediction. Okay, and then it can be a little bit higher or a little bit lower, the temperature now. And this one shows you the predictions, and for the most optimistic scenario, you actually end up with something below 2 degrees Celsius forecast. Okay, this is the Paris Agreement target of 2 degrees. And if you continue emitting CO2 at a high rate, you actually come to 5 degrees. 5 degrees. So how does it now look like in detail? How does it look in detail? And that's shown on the next slide. It's showing you the average temperature distribution globally. Okay, and it shows you for the two scenarios. One, RCP 2.6 on the left side, and on the right is the RCP 8.5 scenario. Okay, and shows you how it will be at the end of the century. Okay, and there's a few things that you note. First of all, you note there's a difference between land and sea. Okay, because the warming effect is more pronounced on land compared to the oceans because of the heat capacity of the ocean, essentially. Okay, so the seawater can store large amounts of heat without changing the temperature too much. Okay, so this is one effect that you can see here. And in particular, in the RCP, in the worst case scenario on the right-hand side, have a look of what type of average temperature changes you get. In Australia, 4 to 5 degrees Celsius. And this is massive. And it's not a global, it's not an average situation that we actually face. We're actually dealing with all these heat waves. Okay, and so how many more heat waves and how much warmer are the heat waves? And how much earlier do they start to actually get something like a temperature change like this? So it is absolutely dramatic, if you think about that. The other effect that you see in these images is you can see the dramatic changes in the Arctic. Okay, also around Antarctica here, but the most pronounced, and this is to do with the melting of the ice, the sea ice in the Arctic Ocean. Okay, that plays a big role. So this is it's truly alarming what I present to you, but you know the story anyway. Okay, let's have a look at the ocean consequences. Okay, the impacts of the ocean. What happens in the oceans, or what roles do the oceans play in all of this?